Let's explore the fascinating world of instruction set architecture, often abbreviated as ISA. This presentation will give you a comprehensive introduction to instruction set architecture. We'll be comparing reduced instruction set computer, RISC, and complex instruction set computer, CISC, architectures and diving into instruction formats. So, what exactly is an instruction set architecture? It's the interface, the bridge between software and hardware. It defines how a processor understands and executes instructions. Think of it as the language that software uses to communicate with the processor. It specifically specifies the instruction formats, the addressing modes, and the register organization that a particular processor uses. Instruction formats define the structure of an instruction, and addressing modes specify how operands are accessed. Let's begin by understanding the reduced instruction set computer RISC architecture. RISC is characterized by its simple, fixed-length instructions that are optimized for high performance. Now, let's look at some of the key characteristics of RISC architecture. First, it has a simple instruction set. Second, it uses fixed instruction length, meaning all instructions have the same size. It follows a load or store architecture, where data processing instructions operate only on registers and data must be explicitly loaded from memory into registers before being processed and stored back into memory afterward. Finally, it supports pipelined execution, which allows multiple instructions to be processed concurrently in different stages, improving overall performance. Now, let's turn our attention to the complex instruction set computer CISC architecture. Unlike RISC, CISC is characterized by its rich instruction set with variable length instructions. Let's examine the key characteristics of CISC architecture. First, it has a complex instruction set. Second, it uses variable instruction length, meaning instructions can have different sizes. It supports multiple addressing modes, providing flexibility in accessing operands. Lastly, it allows memory-to-memory operations, where data processing instructions can directly operate on data in memory without requiring it to be loaded into registers first. Now let's compare RISC and CISC architecture side by side. On one hand, RISC architecture uses simple instructions, fixed instruction length, load or store operations, higher clock frequency, and favors hardware simplicity. On the other hand, CISC architecture uses complex instructions, variable instruction length, memory-to-memory operations, multiple addressing modes, and involves hardware complexity. In summary, RISC prioritizes simplicity and speed, while CISC emphasizes versatility and a richer set of operations. Now let's explore instruction formats. An instruction format defines the structure and layout of an instruction, specifying how it is organized and encoded in binary format. Now let's discuss the common types of instruction formats. These include R-type, which stands for register, I-type, which stands for immediate, and J-type, which stands for jump. Let's dive into the details of the R-type format. The R-type format is commonly used for instructions that perform operations on registers. An R-type instruction consists of several fields, including opcode, which is 6 bits, specifying the operation to be performed. RS, which is 5 bits, representing the first source register. RT, which is 5 bits, representing the second source register. RD, which is 5 bits, representing the destination register. SHAMP, which is 5 bits, representing the shift amount and is used in shift instructions. FUNCT, which is 6 bits, providing additional specification for the operation. An example of an R-type instruction is ADD$T0, $T1, $T2, which adds the contents of registers $T1 and $T2 and stores the result in register $T0. Now let's explore the I-type and J-type formats. The I-type format, or immediate type, is used for instructions that involve immediate values. An I-type instruction includes the following fields: opcode, which is 6 bits, specifying the operation. RS, which is 5 bits, representing the source register. RT, which is 5 bits, representing the destination register. Immediate, which is 16 bits, representing the immediate value to be used in the operation. An example of an I-type instruction is add immediate $T0, $T1 100, which adds the immediate value 100 to the contents of register $T1 and stores the result in register $T0. Now let's discuss the J-type format or jump type, which is used for jump instructions. A J-type instruction includes the following fields: opcode, which is 6 bits, specifying the jump operation; address, which is 26 bits, representing the target address to jump to. An example of a J-type instruction is jump target address, which jumps to the specified target address. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.